This is a very important question. The sensor quality for accuracy and reliability in monitoring buildings is important. And there could be really a big variation among sensor brands and products that are out there, which directly affect the quality and the insights that we derive from the data that is collected from those sensors. So the key challenge that we're seeing is that people are not sensor experts, and that leads to mismatch between the sensor choices and the application. So selecting the right sensor is really important to align with the objectives of the user of the sensor data, and it dictates what is required in terms of accuracy, precision, and range. So when we talk about specifically using indoor air quality sensors in monitoring buildings, a certain level of data quality is really necessary, and the UL 2905 certification it ensures the accuracy and precision of these sensors in the context of buildings, especially commercial industrial buildings. And UL 2905 specifically conducts tests in ISO accredited labs and use quality instruments to do those testing and certification. The abundance of data can really be overwhelming, and so it's really crucial to differentiate between what's valuable insights and needed data versus noise. I believe that the true value really lies in actionable insights that directly impact the building performance, their efficiency, the occupants' well-being, and experience in buildings. So for building owners and operators, the key is to focus on data that aligns with their specific goals. And we know that each building is different, and each building has a different pain point where real-time data can help. It's really not a one-size-fits-all solution, in the same way that buildings are not one size fits all. So this tailored approach prevents, I believe, this data overload, and really ensures that the insights that were provided from the data is both manageable and genuinely helpful. Yeah, I want to say not well currently in terms of integration with mechanical control system automation systems. But here's the thing. Currently, the implementation of automated improvements through IoT technology largely depends on the presence of building management systems that are capable of even integrating IT data into their control sequence. In the US, less than 20% of buildings actually have building management system. So it's, even if it's available and that could happen, you're not affecting a lot of buildings that are out there with IT technology if you look at it from that lens. The primary value, on the other hand, that we're really seeing of IoT in the built environment is the ability to provide previously unknown insights. And we definitely still need expert human in the loop. And the value that they're getting from installing IT is not necessarily enhanced automation, but just to know what's happening in the building. This knowing of what's happening in real time can empower building operators that are the experts to make informed decisions, resulting in tangible enhancement to building performance. I can give you an example. One commercial building owner, real estate owner that we work with, has saved 30% on their water consumption, not by using sensors and automating some control system, but just by utilizing this real-time data from digitizing their cooling towers, which was the most water-consuming system in the building. And then that visibility that they started to get enabled them to detect issues like faulty valves and water overflow and things like that that might have gone unnoticed otherwise. What we've expected, and I think a lot of the industry wanted to do, is to take indoor air quality sensors and put them everywhere where everyone, is in common spaces and working spaces, breathing zones, and things like that. And what we have seen in practice, we've seen most deployment to be on the core and shell indoor air quality monitoring of buildings. When what I mean by that is really focusing the monitoring on HVAC systems, so going to getting data from the supply air and return air and outside air and comparing those data to answer questions such as, am I bringing enough outside air or not enough? Overventilating, underventilating, how is my filtration working, and really using the data in that way. It's not necessarily data gaps that we're seeing because there's a lot of sensors and technology that are out there. I want to say that the gaps in data from buildings really stems from the prevalence of one size fits all solutions. For instance, like with indoor air quality monitoring, there are solutions that offer standard set of sensors, but these may not cover all the necessary IAQ parameters based on factors like the building infrastructure, the location and geography of the building, how the building is used. So tailoring IAQ monitoring to specific needs and those conditions, it becomes then a gap in that building data. So things like monitoring pollutants like ozone and NO2 and CO in transit corridor buildings, or adding total volatile organic compound sensors in art rooms and science labs and schools is often overlooked by genetic solutions. So although they exist and we're monitoring indoor air quality in that building, there is a gap because of really the need. There is expanded need of, under the umbrella of indoor air quality. So we've seen that. And generally speaking, when it comes to the IoT industry, there has been a tension between vertical products and horizontal platforms in the industry. So it's been really crucial for the investors in technologies like this to strike the right balance to bridge the data gaps according to their specific goals. Currently, and I'm sure it's the same for a lot of IoT technologies in the space, that we are still selling to the innovators, early adopters in our industry. And so when we're selling to this audience, innovative technology implementation has often prioritized the improvement and breaking away from the status quo, rather than looking at the financial returns and focusing on ROI and things like that. So we haven't really had to go in that direction in a lot of our conversations with clients and our implementation. So as such, our approach has always centered on providing building owners with a holistic value proposition that emphasizes the rapid time to get real-time data from buildings, and facilitating proactive and efficient building operation because of that. So while financial ROI and energy savings are compelling and could be a byproduct of getting access to that real-time data, our pitch typically extends to mostly showcasing the value of real-time data and the value of getting it really fast and in a retrofittable way in this aging infrastructure. And so that you could get that, or the financial ROIs like energy saving and whatnot, but also other non-financial ROI also that build on top of the real-time data, such as enhanced indoor air quality, occupants' well-being and productivity, better risk management through issue identification, sustainability and ESG compliance, a lot of the regulatory adherences that are now required, also addressing community needs like parents and schools are asking for the data. So these are all examples of non-financial returns and value. The value is really versatile and it can benefit both underperforming and overperforming buildings in different ways. So for underperforming buildings, we come in, IoT monitoring can help with identifying inefficiencies, areas of improvement, so that then potentially you can enhance energy as a great return. And in contrast, if we're being deployed in overperforming building, the data is really used to maintain their high standards. We have a lot of Class A buildings that are that's why they use this, and to identify areas where they can better optimize operations, save money and whatnot. Specifically, I want to reflect on post-pandemic and during the pandemic that Class A buildings were running in an optimized manner before the pandemic, and now we know and we're reading about how there is a big energy waste, there's overventilation, especially with the occupancy being much lower than before. And in the same way with the wildfires, they showed us how external conditions to the buildings are also changing all the time and affecting building operations. So this continuous adjustment, the monitoring are necessary to make sure any type of building, I think, in this day and time, is adjusted to the conditions that are there and continues to operate optimally. A lot of practical applications. Some examples include monitoring and optimizing HVAC systems to improve energy efficiency and indoor air quality. We have some of our customers that use occupancy data for space management and resource allocation, but also to feed into how they look at operating HVAC system based on the dynamic occupancy of tenants and people in the building. Maintenance teams leverage asset condition data for predictive maintenance, reducing any downtime, saving water, like the cooling tower example where the data from the cooling tower allowed them to look at stuck valve, overflow of water, and things like that, and mitigating the issue before it's really costly or impactful. They've also used our platform for compliance reporting, so that they can, especially to meet regulatory requirements. So these are some, practical applications, and we typically tailor each application again based on the customer's goal and their building. We've started in schools a few years back in 2016, actually, helping a few schools with a big issue that I didn't realize until we started to talk. Schools approach us with it, which is power outage monitoring. So that was, I want to say, kind of before, not a lot of implementation of that, until 2020 when actually the pandemic happened. And at that time, as a mom, my initial concern, as we learned more about the risk of transmission and what's the prominent risk of transmission and things like that indoor air quality in my children's school is really important. And there is technology, including ours, that can give us some reassurances of the levels of the contaminants in classrooms, and alert in real time if they're not. So this concern just became a stronger, I guess, driving force behind our approach to schools with our technology. And unfortunately, federal funding, such as ESSER funds, became available for IAQ improvement, and making a lot of those efforts more feasible for schools. As far as breaking into the market, we focused on building trust, really, and demonstrating tangible benefits of the platform to school districts where this technology is new. We know that work from home works, but school from home does not work. So really our mission now has been to kind of help create that environment. Requiring CO2 sensors in classrooms is a very positive and proactive approach to ensure IQ is great in such environment where it's all about education and retaining knowledge. So that's amazing, and it's great to see. Indeed, multiple states, more than I expected, have either passed bills or are working on bills around that. Now, CO2 levels are really also reliable indicators of ventilation effectiveness and can help mitigate the risk of airborne contaminants. So it's great. We do feel that a lot of these bills and regulations that require CO2 only monitoring are really looking at it more from an energy efficiency perspective, and not holistically in terms of indoor air quality solutions, and for occupant health and safety in schools. So I think that's something that we are really trying to advocate for, is those bills to be more encompassing of other types of contaminants, such as particulate matter levels, volatile organic compound levels, temperature and humidity, and requiring all of those aspects to be monitored in real time in these schools to be more holistic in those bills. I think also there is a big thing around. We talked about accuracy and reliability of indoor air quality sensors. Even looking just at CO2, there is a big variance in the technologies that are out there. When we're talking about schools and monitoring these levels and CO2 and PM and hopefully and others, we want to make sure that they are effective and the data is actionable. So in this context and in these types of buildings, we want to see things in language and bills related to minimum standards of accuracy of those sensors. So not just requiring CO2 sensor monitoring or PM monitoring, but also that minimum standard. I think that will make it even these approaches stronger. We don't want to see just checking the box, having a sensor just to check the box. We want to try to see that these regulations and bills bring meaningful improvements to the air quality in schools, so we can benefit students, teachers, and everyone.